So before moving on to the example of neutralizing a strong acid with a weak base, I want to point out a little bit of vocabulary. All right, whenever you have situations where after the neutralization, the ions that are present in the neutralized solutions, if those ions can act as either an acid or a base, what we consider the process to occur is the hydrolysis of water. All right, and the reason for that is when you, for example, when you look here, what can this ion right here do? That ion can react with water to make hydroxide ion and the conjugate acid. So essentially, you are breaking apart a molecule of water because of the presence of that ion. All right, and that process is hydrolysis. Lysis means breaking apart. Hydro generally means water, so it literally means the breaking apart of water. All right, so moving on to an example of the opposite of this situation. It's going to be one where we neutralize a weak base with a strong acid. All right, and there's a lot fewer examples of weak bases as compared to weak acids. So in this case, it's generally going to be, specifically, the only case is going to be an amine, and in this case, we're just going to use ammonia as an example. All right, so if we were going to do this, let's give an example. All right, so a strong acid. In this case, we're going to choose nitric acid. All right, and we're going to neutralize ammonia with that. And what that's going to end up making is the neutralized solution is essentially going to be a solution of ammonium nitrate. So just as before, where we said that our neutralized solution was just a solution of sodium acetate, here, if we take a look at these two dissolved ions, well, what would happen if we evaporated away all of the water that these guys are dissolved in? All right, you would have pure solid ammonium nitrate. All right, and ammonium nitrate looks like this right here. It's just a white solid. It's commonly used in fertilizers. So before going on and calculating what the pH of this solution is, let's just kind of look at this qualitatively and try to understand, well, why would we expect the pH of the resulting solution not to be 7? All right. Well, let's first of all evaluate what goes into this neutralization. We've got nitric acid, and what we know about nitric acid is that it's a strong acid. All right, and we've got ammonia here. And ammonia is a weak base. All right, so when we do this, we could label these guys right here as either conjugate acids or conjugate bases. So this guy right here, ammonium, that is the conjugate acid of a weak base. So if it's the conjugate acid of a weak base, we would expect it to be a weak acid. All right, notice nitrate right here. Nitrate is the conjugate base of a strong acid. So remember, since this is a strong acid, we would expect its conjugate base to be an extremely weak base. All right, so weak that it's not even going to be considered a base. So this right here does not act as a base. But since since ammonia is a weak base, this would be its conjugate base would be a weak acid. All right, so essentially what's going to affect the pH is the fact that this ion right here can act like a weak acid when exposed to water. All right, so first of all, to calculate the pHs, we need to know the amounts of these things that went into the neutralization. Here I'm going to say that we've got a liter of a 1 molar solution of nitric acid, a liter of a 1 molar solution of ammonia. All right, we can calculate, well, that would give us 1 mole of this guy. This would give us 1 mole of this guy right here. So that's the perfect ratio of things that we need, because if you look at the coefficients here, it would be 1 to 1. And that would give us, in the end, the concentration of this would be 1 mole. All right, we get that from a little stoichiometry. And the total volume of the solution would be the total volumes of these combined. That's 2 liters. All right. So the total solution molarity of this, at least before the hydrolysis reaction occurs, would be 0.5 molar. All right. So we're going to go about this setting up the chart. All right, so before the hydrolysis reaction, and you're going to have to think about this, just a little mental exercise, because it's not like you make this stuff and then someone says, okay, go, and this reaction starts. As soon as this stuff starts to get produced, it's going to be able to interact with water. So do we ever have a case where we actually have this concentration of ammonia or the ammonium ion? No. All right. When the ammonium ion gets formed, this reaction can start to occur. But we can still calculate what the ending pH would be as if this were to be the case. All right. So let's consider this theoretical situation where we have 0.5 molar of ammonium ion and we haven't had the reaction occur yet. All right. And then we can set up what the ending concentrations would be. And so we could set up a Ka expression right here based on this reaction right here. And again, to figure out what the Ka is of our ammonium, we do that starting from knowing what the pKb is of our ammonia. All right, and we can get that from the data table in the IB booklet. All right, so the pKb of ammonia is 4.75. That allows us to figure out the pKa of ammonium is 9.25, and that the Ka would be this value right here. So we could set these guys up equal to that. We could plug our amounts in. Again, I've done a little bit of a shortcut right here where since this is a weak acid, we could assume that this is essentially the same as 0.5. And we could calculate what our X is. All right, so remember what our X would be. X represents the concentration of hydronium ion, and that is what actually goes into the pH equation. So once we know this, we could calculate the pH from that, which would be this right here. All right, so again, this pH indicates that the resulting solution would be slightly acidic. And hopefully that's what you would anticipate if you were to mix a strong acid with a weak base, that it wouldn't come to be completely what we consider a neutral pH because it's a strong acid with a weak base. All right, and that's what the pH would be. So hopefully that makes sense. You will be given some practice problems where you can calculate these pHs, and trust me when I say that it does get easier with practice.